All right, Mike's magic banking rule is real simple. The number of sticks that you need to make a bank on any PC is the size of the external data bus divided by the width of the RAM stick. Keep in mind that since the original Pentium, the external data bus has been 64 bits. It's never changed once. So the top part of this equation is always 64, divided by the width of the RAM. So far, you guys have only seen 3 types of RAM. You've seen the 72-pin SIMs, which I told you by definition are 32 bits wide. You've seen the 168-pin DIMMs, which are by definition 64 bits wide. And you've seen the SO DIMMs, 72-pin, which are by definition 32 bits wide. So there's really only 3 different numbers we can put on the bottom. We know the top number, and there's only 3 we can put on the bottom. This becomes fairly moot. You ready? So let's say I've got a Pentium 4 system. The Pentium 4 system has an external data bus of 64 bits. And I'm using 168-pin DIMMs in this system. How many DIMMs will I need to make a bank? Well, the size of the external data bus is 64 bits. The width of a DIMMs is 64. So I only need 1 DIMM to make a bank on that particular system. Banking is critical because that tells you how many sticks you have got to put in your system in order for it to boot. For example, if that equation had come up where I needed 2 sticks, I am going to have to put a minimum of 2 sticks in my computer. Now, understand, I don't care how high these sticks are. I don't care if they're 16 meg or 32 meg or whatever. I physically have to put 2 in if that's what my equation came out to be. In this case, I only need to put 1 stick in. It's not a Pentium 4, it's a Pentium 3, but it still works the same way because it still has a 64-bit external data bus. If you take a look on this system right here, you'll see I've got 1, 2, 3 slots where I can snap RAM in. Since I know by definition, by my equation, I only have to put 1 of these sticks in to make a bank, what we can say here is that this system has 1, 2, 3 banks. Right now I have 3 banks, but they're unpopulated. Let me populate one for you. We'll actually go into RAM installation in a second, but at this point I just want you to get the idea of the actual RAM itself. So I've got 1 populated bank and 2 unpopulated banks. It's very common in the RAM world to have extra spaces open. So tell me, why do I have extra spaces? Let's say that that RAM stick I just threw in there is 128 megabytes of RAM. Why did the motherboard manufacturer give me 2 extra slots? That's right, for expansion. Down the road, if I want to, I can add more RAM. As I add more RAM, each RAM counts on top of the other one and gives me my total amount of RAM. For example, if I've got a 128 megabyte RAM stick in there, and then I put a 64 on top of it, that's going to be 192 megabytes of RAM. They're additive. They all add together. All right, 1 is easy. Let's do the banking formula again, except this time we're going to make it a little bit more complicated. Okay, we're going to go back in time just a smidge here because with 168-pin DIMMs so common today, we don't really have to worry about banking too much. And I'm going to use 72-pin SIMs. Now remember, I told you that 72-pin SIMs are by definition 32 bits wide. And so using the formula, the size of the external data bus is 64 bits divided by the width of the 72-pin SIM, which is 32. That means I need 2 SIMs to make a bank in my Pentium Pro system.